We are going through question 1, right? Of our tutorial 2. This is not going to be hard. We know that, so we can handle it. Okay. Hopefully you have done some on your own. Hopefully you've done it on your own. You've tried it, and now you are confirming. So these are just my solutions. Remember, these are just my solutions. Okay, and I'll be showing you from where I get it from. So this topic is on the average rate of change and the instantaneous rate of change. These questions from question 1, they're on average rate of change and instantaneous rate of change. Now, average rate of change, the formula that you must know at the end of the day is to know that the average, we say that the average rate of change, the other average rate of change of y equal to f of x is going to be, you can say with respect to x, whatever, or they can say of y equal to f of x with respect to x over the interval x1 comma x2. So whenever they say the average rate of change, the moment you hear them say, or the moment you see that word average, then it's going to be geometry type of thing. So it's going to be algebra like. So it's going to be delta or change in y over change in x. That is going to be your average. Your average. Whenever you hear the word average, whenever you see the word average, whenever you read the word average, it means change in y over change in x. Okay, average is not that hard. And for us, since we'll be having a function, it will be f of x2 minus f of x1. Remember that the change in y is like y2 minus y1, and y you can write it as f of x. Okay. If we have as an f of x, so it'll be f of x2 minus f of x1 over change in x, which is x2 minus x1. This is going to be what it is. You say the average is equal to change in y over change in x, which is equal to f of x2 minus f of x1 over x2 minus x1. Sometimes you can see them say, or you can say it'll be equal to f of x1 plus h. H will be the difference between x1 and x2. So like you have x1 here, right? And if you move xh, you get to x2. So h is the distance between them. So if you say x1 plus h, it will be x2, okay? Minus f of x1. We know that x2 is just what? x1 plus h, right? Then it will be all divided by x1 plus h again, minus h minus x1. Okay, you no longer have the f of whatever. And this x1 and x1 will cancel. You just remain with an h. So you can say this is what they'll say. Either you're going to use this, which is the one we're going to use most of the time, this one, or at some point we'll use this, which leads us to the instantaneous one. This helps us to understand the instantaneous one. So the average, change in y over change in x, we're going to use this f of x2 minus f of x1 all over x2 minus x1. And f of x2 and f of x1 are going to be things that we are going to get by substituting x2 and x1 into the function itself. This is not going to be anything complicated. So I'm going to remove this other part, and we're going to deal with this to say the average change in y over change in x is equal to f of x2 minus f of x1 over whatever. So now I'm going to underline. Let's go through the solutions, because the first part says find the average rate of change. So average, the moment they say average, is change in y over change in x, right? So, and you're going to do that. Average rate of change in the unit price of a sweater. And what did you have? F of q. You didn't have f of x, you have f of q. So you're going to write to say f of q is equal to 144 minus q squared, right? This is my f of q. It's 144 minus q squared. So now they said, find the average rate of change in the unit price. So the average rate of change, we need to know where we are starting and where we are ending. Sometimes they say, find the average rate of change for the change in time up to 3 seconds, okay? If they say average and they say time up to 3 seconds, it means it's coming from 0 to 3. So just be careful if you are ever to get such a question. But anyway, here they give us things that are very easy. So here I have my FQ being this, right? So this is a function of q, it's not a function of x. So I'll be having q1 and I'll be having q2. And I'll be having f of q1 and I'll be having f of q2. So here they're saying if the quantity demanded is between 4,000 and 5,000. So it's going to be find the average rate of change in the unit price. If the quantity demanded is between 4,000 and 5,000. So I'm going to say part I. We are doing part I. You'd say let q1 be equal to 4,000. And you can say, comma, q2 be equal to 5,000. Okay. So now you can say f of q1 will be equal to 144, wherever there's q1, I'm putting wherever there's Q, I'm putting Q1, right? F of Q1 is equal to 144 minus Q1 squared, which is going to be, you can say, what is my Q1? 4,000. So you'll be saying that F, it is equal to 144 minus 4,000, okay, squared. And we can get my F of Q1. What is my F of Q1? It is going to be, what is my F of Q1? 144 minus 4,000 squared, right? And I can also have my F of Q2 because it will just be 144 minus Q2 all squared, which is going to be 144 minus 5,000 all squared. Minus 5,000 all squared. And I get my solution. Then once I have it, I'll have the average rate of change. Average rate of change is going to be equal to change in y over change in x, if you want to put it like that, which is going to be f q2 minus f of q1 divided by, okay, so it's f of q2, which is the y2, right? F of q2 minus f of q1, all divided by q2 minus q1, okay? Is divided by q2 minus q1. This is going to give me my thing. What is my f of q2? So we would now just take from here what f of q2 would be, and we are going to substitute and we'll get our solution. So this is just what happens for this, and you'll be done. F of q2, you can then call it f of 5,000, okay? Because q2 is 5,000. Yeah, f, you can call this f of 4,000, and that is how you get it. And we'll be getting our solution. So let's get our solutions. I'm going to punch them in the calculator now. And what do I get? And if we put here f of 4,000, you would see it being negative 15. If I put this, you'd say negative 15,009, negative 15 million, sorry, 999,856. Then for my f of 5,000, I would get negative 24,999,856. Now, when I come here, I would say, okay, what is this? Changing y over changing x. So f of q2, I got it as, so I'm going to say, oh my goodness, here, negative 24 million rather, 999,856. Minus, please be careful here, it's minus f of q1. And f of q1 is negative itself, so it's going to be minus, then you put negative 15,999,000. Surely you won't make a mistake here. 856. It's not going to happen. Don't do that. Here, Q2 is 5,000 minus Q1 is 4,000. So there we go. We put these two values. Punch in the calculator should get negative 9,000. So what is this? This is the rate of change. So it'll be on a graph, the gradient will be going down because it's a negative 0. So that means what is the rate of change in the unit price of a sweater? Okay, what is the rate of change in the unit price of a sweater? It is negative 9,000. That is the rate of change, because there you had the function from the clothing manufacturer, and we just put in these values, and this would be your solution, and you'll be done. Okay, negative 9,000. It is the average rate of change in the unit price of a sweater if the quantity demanded is between 4,000 and 5,000. It's reducing by 9,000. Either way, here we have it. Now we'll go on to the next. Goodbye for now.